The last time we talked about binary ionic compounds naming, where we talk about metal type 1. So we need to continue now with metal type 2 as we promised you. So in metal type 2, if it is we are naming binary compounds that contain metal type 2, then how do we name them now? We don't just directly go, right? We need to actually do some basic calculation. We say metal type 2 are metals whose oxidation state, or when they are forming ion, when they are forming bond with other ions, right? They exhibit different oxidation states. So they can have, with the same compound, they can have a particular, they can donate a particular number of electrons. In another one, they can share and they can donate another particular number of electrons. That's what we basically call the oxidation state. For example, see this one, CuO, right? And then Cu2O. So we see this compound, copper and oxygen, copper again and oxygen, right? But then the same oxygen, but why is copper now copper here with one and then copper here appearing twice? What's going on, right? So copper is one of the metal that we see that is not metal type 1, it's a metal type 2. And we say metal type 2 can have what different oxidation states. They can be +1, +3, +4, depending on the bond that they are forming. So copper, CuO and Cu2O are as critical example that I can give you. But then before that, let's look at the non-metals. For the non-metals, we said again, we are going to be focusing on these guys mostly. So I'm circling them again for you. And then for them, we said carbon is C4 minus, N is N3 minus, E3 minus, oxygen O2 minus, sulfur is S2 minus, F minus, all the group 7 they are Cl minus and Br minus, I minus. So we need to know these basic ones. Why? We need to know that these people, these are the number of electrons that they readily give when they are forming their bond. Right? For example, the CuO that we see right now, oxygen is there. So these are the non-metal. Okay. In forming this bond, we want to form a stable bond. A stable bond. So the non-metals would donate some number of electrons, and then we share some number of electrons, and also the metal will also share some number of electrons. After they share, and then there is a balance. After they share each other, they combine, and then they balance, right? The total charge on them, total charge on them, the total charge on the entire species, resultant species, will just be equal to 0. Everything will be equal to 0. This is not O, this is not O, this is not O, this is 0. Right? So if you are taking copper, for example, we know that oxygen generally donates how many electrons? 2, right? Because here we say it's O2 minus, so 2 electrons from oxygen, 3 from phosphorus, 3 from nitrogen, copper. So this basic one, you need to know them. You need to know them. Right? So if you see CuO, we see that CuO. So readily oxygen already, you have to know that okay, oxygen is a non-metal and it is readily able to contribute 2 electrons in its bond. And when we come to copper, copper is a metal type 2. So we don't know how many electrons it's giving now because it varies. That's what we mean. That metal type 2, it varies, so we don't know. So before you can name them, you need to be able to calculate the number of electrons that the copper is giving, right? So we said in a bond, right, the sum of all these things should be 0. So if I say bond A, so X, let's say N here, and let's say the non-metal, let me call the non-metal, let me represent it by Y, M here. So what happened is that, oh, it's not a right order. So let me just do it. M, N. So if this is the bond, a bond like X is a metal and Y is a non-metal. Yes, a bond like that, and these are their frequencies. Like frequencies are just the number Cu2. The 2 here is like M, and the N here is 1, right? For Cu2. So what you have to do is that, okay, for M, right? So we are going to take M. Let's assume that this guy can donate, can give us some number of electrons, which is X plus, this is the frequency N times the number of electrons that this guy can donate. Let's say it's small y. will be equal to 0 because the entire charge will be on it, on the entire substance will be 0. That's what is equal to 0. So we have to calculate that. Okay, you need to know the frequency, which you can see from the compound, times the number of electrons that it is likely donating in that particular bond, plus the other one to n times n is the frequency, right, of this particular y, right, times the number of electrons that it readily donates in a bond will be equal to 0. If we are applying this example on the copper 2, the copper CuO right now, right, CuO, then we are going to have, and copper is having a frequency of 1 here, so CuO is, the frequency is 1, so it's going to be 1 times x, that because we don't know for copper here. Now oxygen is 1 here, so oxygen, the frequency is 1 times, how many electrons are oxygen giving a bond? We say 2, right, will be equal to 0. So that's what we are doing here. If you do this, you'll be able to calculate for x. But then you know that for the oxygen, what are we having? They are all negatives, right? They are negative. So what we are going to have, instead of just writing 2, is going to be negative 2. See the charge here. Oxygen is negative 2. So if you're having phosphorus is 3 minus and 3 electrons. So I was just using the number of electrons to tell you that, okay, 1 times negative 2 is equal to 0. So what we are doing that, we are going to have 1 times x, which is x, right? Plus 1 times negative 2 is going to be negative 2 equals 0. So s minus 2 equals to 0. So x is equal to plus 2. So it means that the number of electrons that this guy is giving is 2 in this particular bond. If that's the case, then how do we name this one? So how do we name this substance? So the naming the substance follows the one that we did. But then before you mention the non-metal, you need to state this number, which is the oxidation state. So it's going to be, you mention the metal first, plus oxidation number, oxidation or coordination, oxidation number, then you add the non-metal. So anion. So you add the anion name. We say anion ends with IDE for those guys, right? So here, if you have this CuO, in this CuO, what are we having? Metal is copper. So we are going to say copper. What's the oxidation number? You put the oxidation number in a bracket. Oxidation number is 2, right? It's in Roman numerals. Don't just write it 2 here, but let them be in Roman numerals, right? Then what's the name of the anion? The anion is oxide. Oxygen is oxide, right? So copper 2 oxide. If it were just metal type 1, we should have just say copper oxide. But because copper is not a metal type 1, metal type 2, we need to actually calculate for this oxidation state, oxidation number, which is what we calculated here. That's why we just separate them. That's the difference between naming with metal type 1 and naming with metal type 2. Let's do for this one. Let's do it for this one. So keep in mind what this guy is, right? That's the naming for. Let's calculate the oxidation state of the other one. I have Cu2O. So we know that 2 for copper, right, times x, because we don't know for the x. But then for the oxygen, here is 1. If they don't write anything, it's 1 times oxygen is negative 2. Like we said, it's 0, equal to 0 always, because the thing is neutral. It's a neutral substance, compound, so it's 0. So you have 2s minus 2 equal to 0. So 2s is equal to positive 2, because the 2 will go to the other side. So divide 2 by 2, you have s is equal to plus 1. At the end of the day, the oxidation number is plus 1. So we have copper into bracket 1 oxide. So you see copper alone having different oxidation states, different substances. This is the behavior of metal type 2 substances. Let me give another example. So for the metal type 2, you need to actually calculate their oxidation number, put it in the middle before making the non-metal. That's just the difference between what we learned previously and what we are learning currently. Let me go to ion, another common substance that behave like that. So I have Fe2O3. So I know the oxygen is, so for ion, right? Ion is 2 times X because we don't know it here yet. 3 is the number here times. We know that oxygen, we have to know those ones. Oxygen is -2, right? So equal to 0. So here is what I say. Oxygen is negative. If you are working with sulfur, is -2, equal to nitrogen is -3, carbon is 4. This guys is 1 and those cap, right? So now for these guys, what am I having? Solve for this is so 2x. This time is this will give me -6 equals 0. So 2x is equal to 6, and then x will be equal to +3. So it's going to be ion into brackets 1, 2, 3, ion 3 oxide. Ion 3 oxide. As simple as that. So if you have FeO, what do you think about this one? So this one will be 1 times x for the ion plus 1 times oxygen is -2. We are going to have 0. So I have x will be -2 will be equal to 0. S is equal to 2. So at the end of +2, so you're going to be ion 2 oxide. You can try with other substances that you know, right? So you see ion ion alone with oxygen is having a +2, and then with oxygen again is going to be +3. So that's how we actually evaluate or calculate the oxidation state of measure type 2, right? You take your time. If you notice the measure type 2, then you need to do this exercise. You multiply the frequency by the oxidation state of each, and then you just name them. The oxidation numbers are actually should be in Roman numerals, right? Roman numerals, before you can actually work with them. Which elements should I combine now? Okay, let me give you something like FeBr3. So it's going to be 1 times x, right, plus the frequency is 3. And for bromine is in group 7. We take group 7, they are all -1, -1 as they are charged. So you become -1 equals to 0. So I have x minus 3 equals 0. So s is equal to +3. So the name is ion 1, 2, 3 bromide, because bromine is going to be bromide. Yeah, this is the naming for metal type 2 combining in a binary ionic compounds. So in binary ionic compounds, yes, if you give metal type 1, you then just mention the metal and the anion name of the non-metal. If it is metal type 2, do this exercise to evaluate the oxidation number. When you're able to evaluate the oxidation number, then you now, before you mention the name of the metal, you put the oxidation number in Roman numerals before you add the anion of the non-metal, the name of the anion of the non-metal, then you are okay. Yeah, let's continue in the next session.